Thank you for joining us this morning. It has to be very different. First and foremost, I think we need to, on my part, I need to apologize because for some reason, the initial presentation when we tried to record it didn't really work. So there were some technical issues. So we'd like to thank Dr. Chua again, and of course Frederick, for redoing the whole thing altogether. And very much thanks to, of course, the Malaysian Smart Factory 4.0 and of course Baduf. Now, moving forward, today we're talking about optimizing machine utilization. And in this big topic, or the big umbrella on operational technologies, we always want to see how we move forward and how we keep the machine as optimized as possible, or how can we keep the machine at its optimum level as best as possible. Then of course, then there's a lot of things that we need to actually consider, and maybe we need to take note of. All right, so before we move ahead, all right, just some quick ground rules. All right, so first and foremost, please mute yourselves. And if you have a question later on, please switch on your video, unmute, of course, yourself, and introduce who you are, and please ask away. Now, so this is today's agenda. We of course have a quick welcome remark from my side. Then of course at the end of the day we shall move towards Dr. Chua, who will introduce us how do we keep our machines at its optimum level. Then Frederick from Baduf Automation will discuss about how we use data analytics for conditional monitoring. All right. Then we move on to the Q&A, and then we end the session. All right. Now, first introduce Dr. Chua. Now, Dr. Chua is currently the head of the Malaysian Smart Factory 4.0 under the Selangor Human Resource Development Center. He obtained his PhD in Control Systems Engineering and Bachelor's of Engineering in Mechatronics Engineering from Monash University. His key area of expertise lies mainly in the area of control and automation systems, fault detection and identification, and predictive maintenance strategies, which are widely used in Industry 4.0 applications. He is also appointed by the Malaysian Productivity Corporation in collaboration with the Machinery and Equipment Productivity Nexus as one of the mentors for the Productivity 1010 initiative to support the industry's India journey towards digital transformation. As the head of Malaysian Smart Factory 4.0, Dr. Chua and his team are focusing in delivering high-impact talent development programs to accelerate the growth of local talents who would be the workforce in supporting the growth of Industry 4.0. The programs developed by his team at the Malaysian Smart Factory 4.0 are also able to support the industries and community towards achieving sustainable digital transformation through high-impact talent development strategies. Thank you very much. Let me end my screen. So Dr. Chua, there it is.
Sure.
So the screen is now yours. Dr. Chua, please go ahead.
Okay, so thank you very much, Kenneth, for the quick introduction and for doing this webinar again for everybody due to the initial technical errors that we had for the recording session. Now, this afternoon, what we are going to share with you is, regarding the optimizing your machine utilization level, right? And how do we keep our machines running at optimal level using machine health monitoring methods, right? And these are methods that will actually help to keep your machines running at optimum level, right? And also help you to identify where are the root cause of the machine with regards to, it's running for a long period of time, there are wear and tear and so on. And this will actually help to actually, solve certain issues with regards to your machine so that you can keep them running at optimum level over time, right? So let's go to the first slide. Now, the first part, we'll talk about data-driven strategy towards manufacturing cost optimization. And then we'll move on towards looking at machine health monitoring methods for optimum equipment effectiveness. And the last part of it, we will actually talk about machine health monitoring strategies, which we can actually use to actually obtain data. And that data can be actually used to gather insights about your machine and run predictive analytics, and eventually will help you to optimize your machine utilization. Now, the first part about Industry 4.0, as we all know about it, and we all see the stages of the Industrial Revolution, right? So Industry 4.0 for us is a journey, right? And there are many stages in the Industry 4.0 development path. So the first part of it is, of course, talking about digitalization, where we talk about computerization and connectivity. Now, when you computerize and you connect different devices, different machines, that's where you obtain a good form of infrastructure for digitalization. Now, the next part of it is then how would digitalization benefit an industry, right, through an Industry 4.0 methodology. So the next part of it is actually how data, right, can be used to actually provide visibility, right? And visibility here talks about what is actually happening, right? Therefore, you are able to see in real time what is actually happening to your machine operations and so on. Then you talk about why is it happening, right? Once you obtain a lot of data, you are able to see the data happening in real time. Then you are actually able to understand what is actually happening and why is it happening. Therefore, obtaining transparency. Now, once you have visibility and transparency, so the next step is, having the ability of being prepared, utilizing those data, therefore identifying what will happen, right? Therefore, being prepared with predictive capacity. And once you have more predictive capacity, you are able to then adapt, right? You have adaptability. Hence, you can utilize this data, this information, and that predictive capability to do your own optimization, right? And you know what would potentially happen. You are able to forecast what will potentially happen, and therefore take the right steps and methodology to mitigate them, right? So the whole idea about Industry 4.0 is actually realizing how data can actually create value for you, right? And how does data create value, right? For an industry or for a manufacturing industry, you utilize data to actually reduce your overall time delays. So we talk about time delays where, you have something that happened to the machine, right? Let's say something happened, therefore your machine breaks down. How long does it take for you to know when your machine breaks down? Is it the next half an hour? Or is it almost instantaneously? Therefore, a single insight delay, right? The time for you knowing that your machine breakdown is a time delay for you. Now, the next part of it is analysis, right? To look at your machine when it breaks down, you want to analyze what is the root cause. How long do you take to analyze? How long do you take to make decision? And how long do you take to take an action, right? So all these time delays, if you are able to minimize them, all right, or to reduce these time delays, or even mitigate them, therefore, overall, you actually can reduce a lot of costs, because in every day of a manufacturing industry, right, every day, the only constant that you have is time, right? So every one of us have 24 hours in a day. Your shift time is also fixed already. So therefore, the only way to optimize your cost is actually to maximize your potential and productivity during the time that you have, right? So talking about machine health monitoring, how does it actually benefit the industry over time? Now, if you look at this graph of a P to F curve, P to F curve here says that your potential failure to functional failure curve, right? So every equipment that you purchase, there will be a time where your machine will reach its functional failure, right? So if you look at this curve, when you first buy a machine, your machine should be working at optimum level, right? It should be working at optimum level. Therefore, you know that when you buy a machine, it's brand new, it will always work at optimum level. Now, over time, then it starts to degrade. Well, because due to wear and tear or due to its lifespan, it starts to degrade because every part of the machine has its own life expectancy, right? Similar to a car, right? When you drive a car, there's a mileage meter, and every 10,000 kilometers, you have to send your car for servicing or to change certain parts. Now, machines are the same, right? Over time, it will slowly degrade or wear and tear, and until a point, it reaches functional failure. Now, what are the sort of symptoms that the machine will provide, right? So let's say you talk about a motor, right? For example, a motor will tell you that it's breaking down maybe when it starts to heat up, right? You start to see a lot of heating. Or maybe it starts to give a lot of noise, right? For example, if let's say your car starts to break down, you give a lot of kind of noise. Machines are the same, right? But you don't want to reach a point where when you start to see smoke, then you know that your machine is going to break down any minute, right? You want to be able to have some time, right, to actually mitigate your machine from reaching its functional failure. Therefore, you will utilize other techniques such as, vibration, ultrasound, or many other kinds of techniques or power monitoring to then identify issues at an early start before it actually starts to break down, right? So this will actually help to keep your machines running at optimum level. So the whole idea is utilizing data, right, or machine data, similar to how, we run diagnostic analysis of human bodies, right? We do the same for machines as well. What we do is we put in sensors on the machines, right, to do what we call as condition monitoring. And once we actually look at condition monitoring, when we continuously check the condition of the equipment over time, we are actually able to identify the rate of degradation over time, right? And once we identify that, we know when it will actually fail functionally, the point that you will fail functionally. So the next step of it is actually to predict when it will actually start to fail, right? Or start to give some signals of the machine failing. And therefore, we are able to put in the right mitigation steps to lengthen the P to F interval so that we have sufficient time to maintain it until it reaches its functional failure. So it's moving from the point of reactive maintenance. Reactive maintenance is when, your machine hits functional failure, when it starts to smoke, right? Therefore, you know that, okay, I need to go and fix it now, right? So then we move to preventive maintenance, where preventive means that you have scheduled downtimes, scheduled maintenance strategies, right? So you maintain it regularly so that you wouldn't break. So a similar example is like your car, right? You have scheduled maintenance for your car. If you actually go beyond that scheduled maintenance, potentially your car may have future issues that we are not aware of, right? So then we talk about predictive, right? Predictive is basically using data, right? Data that you collect from the condition monitoring to actually do health diagnostics of the machine, and therefore identifying when is a point that they will start to fail, right? And prescriptive, of course, that will go into a bit more beyond, where the machine will actually be able to utilize AI methodologies, right, to actually prescribe to you what is the potential analysis and actions that can be taken to solve your issue, right? So therefore, we talk about the 4 types of data analytics, right? The first step is always descriptive, basically what is happening. Diagnostic, why is it happening? Predictive, what is likely to happen? And prescriptive is what do I need to do, right? By all means of all different data analytics strategies or types of data analytics, as the complexity increases, the value also increases, right? Because once you reach a certain level of prescriptive capabilities, it will definitely give you a lot of value to your business operations. But of course, it's also a bit more complex to implement, right? It requires a lot of data. It requires a lot of strategy in terms of collecting the data and then utilizing that data to make the right decisions for you, right? So how does data analytics or, how does data automation help you to actually provide you with useful information to actually optimize your machine utilization? So if you think about Google Translate, right, when we speak in this webinar in English, and if you want to translate it, to, let's say, Spanish or any other languages, right, you can do that through Google Translate. Now, the same thing for machines. What we are trying to do is to get the machines to tell us a story, right, to tell us what is actually happening to them, right? So sensors are placed into the machines for them to tell us what is their current status, what is going to happen, and what is actually happening in the machine. So let's say if we look at this Google Translate over here, it's translating a machine signal where it is telling you what is happening, where he's telling you that the machine has a problem, anomaly is detected. Why is it happening? Basically, the motor has some faults. And what is likely to happen? The machine will shut down in 15 minutes because there is motor faults, right? So therefore, basically, you are already translating what the machine is trying to tell you through the signals that you are collecting. So this is basically how data analytics is used to actually optimize your machine utilization. Now, the simple way of doing descriptive analytics is basically trying to source out what is happening, right? And to get that, basically, you can use real-time OEE calculation, where you can look at the overall availability, performance, and the quality, right? And straight away, by doing OEE calculation, you can already identify why is it happening, by identifying the root causes, which causes your losses, right? Your 6 big losses. So why is it happening when you have a lot of breakdowns? Why is it happening when you have a lot of minor stoppages? Your speed is not at its optimum level, and why you have a lot of startup losses. So asking a lot of questions on why, once you identify the 6 big losses, you're actually able to drill down to the root cause of what's actually happening to your machine, right? Or your manufacturing operation by using diagnostic analysis. And then of course, once you have a lot of data running in your machine, right, you're able to look at your machine running over a long period of time. Then of course, now you can now start to look at, what is likely to happen by using data to forecast what is going to happen in the next, what happened in the next half an hour or the next 1 hour. So you're then able to identify, okay, right, something is wrong with my machine, because you start to see some error deviation over here, right? Because your forecaster is supposed to look good, but suddenly you start to have some deviation in your data set. So from here, you're actually able to straight away identify that, okay, my machine is having a problem. I need to start looking into it now, right? So this is actually how you can utilize data to do anomaly detection, right? Because when you buy a machine, you will never expect the machine to fail immediately, right? So of course, your prediction of your machine health would always be good over time, right? But over the period of time, you start to see maybe your motor position is deviating, your torque is deviating, your power consumption is deviating, or something is happening in your machine. So therefore, you want to utilize that kind of forecasting data to actually look at the error, the amount of error that is estimated, right? And therefore, you're able to detect an anomaly from happening. So this is how you utilize data-driven strategies to actually look into your machine health and therefore optimize your machine utilization. So the 5 criteria of importance for quantity and quality of data is really looking at the volume, right? The V for volume, the size of your data set. It shouldn't be that you just collect data for 1 day and then you can say that, okay, I know everything about my operation. My machine can now do prediction for the rest of the year, right? It's not necessary like that, because every machine has its own trend, has its own behavior, and therefore having more volume of data will only help you to improve the accuracy of your prediction, right? And velocity. Now, if your machine is operating at 5 seconds at 5 seconds, right? Every operation is 5 seconds. And if you collect your data every 10 seconds, you're actually sampling your data at the wrong sample rate, right? So velocity actually tells you what is your sample rate, right? And therefore, if it's running at 5 seconds per part, therefore you actually need to sample at a shorter time sampling rate, maybe every second, right? To get the valuable data for you. Now, variety basically looks at a variety of data set. Now, if you only analyze only one set of data, one type of data, which is the variety, you may not be able to see the bigger picture, right? If you have more information, more variety of data sets, you actually get more flavor in your data, and therefore you actually are able to make accurate decisions and predictions, right? Data accuracy, which is also called veracity, is also important, right? You need to ensure that your data is accurately measured, right? Let's say temperature. If you're supposed to measure at 37 degrees Celsius, but your temperature sensor that you put in is measuring at 30. So that offset is already very, very big, right? So you need to always ensure that there is some level of accuracy. And of course, the last part will be the value of your data. Collect data that is valuable to you and therefore useful for your insight, right? And your decision making. So machine health monitoring can always help in terms of keeping your machines at optimum level, because you are able to look at your machines, to be able to identify issues at early stage, reduce your overall unscheduled downtime, right? Provide real-time machine insights, right? Improve your machine utilization, reduction in maintenance costs, because you don't maintain your machine just when you start to see smoke happening, right? Which is a bigger issue, right? Improve your production output, and identify more data-driven root cause kind of analysis. So therefore, by looking at all this, you're actually able to keep your machines running at optimum level, right? And therefore reducing your overall cost of downtime or losses. So how do we then utilize some of the methodologies or strategies to do machine health monitoring? The first step is actually to look at, what kind of data that your machine is actually providing to you. Now, machines will give data in 2 forms. One is digital, one is analog signal, right? Digital signals are basically, on-off signals, 0 or 1, right? And analog signals basically will give you a variety of data sets. For example, a digital signal is like a proximity sensor, right? If there's a part or no part, it's either 0 or 1, right? Let's say temperature. Temperature is not like 0 or 30 degrees, right? It has 0, 1, 2, 3, all the way until 30 degrees. So that variation gives you your overall analog signal variation. And therefore, from there, you're actually able to identify more information of your machines. So once you look at these two data sets, the next step is how do we collect that data? So there are two types of methods that you can use to collect your data, right? You can look at using an IoT gateway, right? For example, like this. You can collect your digital input, you can collect your analog input using this kind of IoT gateway, different kind of signals. Now, there is also a technology called IO-Link, right? And IO-Link looks at smart sensor technologies, right? So you have digital or analog input that you can just plug inside this IoT, inside this IO-Link hub here, and then straight away you can measure your data, and you can also actuate certain actuators, you know, from here, like lights or cylinders, right, based on the data that you collect. So this is a direct application of technology where this information about IO-Link technology can be shared more by Frederick later from Baluf, where you can see how this technology is utilized for the industry to collect many different type of data and to also look into condition monitoring. So for OEE, by collecting your digital signals, you know, you can straight away calculate your overall equipment effectiveness, right? You can straight away look at, how is your availability from just your tower light signals. Performance, you can utilize, sensors like input and output sensors to actually see your overall performance. Quality, you can utilize certain sensors or even push buttons to identify the quality issues, and straight away build a dashboard like this, which you can already start to see in real time what is actually happening to your machine. So it starts to give you your descriptive and diagnostic analytics already. Now, of course, over time, if you want to look at, condition monitoring, where you can put smart sensors like vibration sensors over here using IO-Link technologies. So this is actually running in our lab at the moment, where we connected the smart sensor to the motor. And once we visualize the data through a dashboard like this. Once we turn on the motor, you can start to see that, the motor starts to emit certain vibration, certain temperature levels as it is moving. And here the motor, we purposely put it at an angle so that it shows that there's certain imbalance or vibration happening. And then straight away, if the motor is vibrating too much, it will start to trigger a warning signal on the dashboard like this. So by looking at this in real time, you are actually able to then identify, okay, there's something wrong with my motor, I should go and check it out, right? Especially when you look into conveyor systems or you look into pumps, right? If you put these kind of sensors, like vibration sensors, you're already able to gather a lot of insights on what's actually happening to your machine over time. So these are some of the technologies that you can use, right? And although we think that, okay, wow, it looks very complicated, it looks like it's not easy to implement, but what I would say is actually quite straightforward, right? All you need is basically a master hub, you need a sensor, and just connect it. Utilize, drag and drop tools such as like Node-RED to actually connect these sensors together, and straight away visualize your data straight in a dashboard like this. So this is actually a very straightforward application to really utilize, the hardware and software integration, collect the data that you need, and you can straight away visualize this data over a period of time, right? You can actually start to see, different kind of trends, right, from your motor, and start to see snapshots of data or behavior over time, and then start to make your own predictive analytics. So the first step is always on data collection, right? We talk about data generation as a level 1, and then you look into visualization, like what you saw just now into your vibration data. Then you talk about storage, because when you want to do predictive analytics later on, you need to store your data, right? Without storing your data, it's very difficult to identify what is the trends, what is the data that you want to look at, and then formulate it, right? Look into what kind of data you're measuring, formulate an equation of effectiveness, and then only look into analytics. So these are the 5 levels of data automation maturity that industries can look at to really get started, right? And of course, when you look into in deep down how this level looks like in terms of a shop floor topology, right? We start from level 1 at the bottom, collection of data. Then level 2 and level 3, store and visualize. Level 4 to formulate, and then you look into level 5 when you look into data analytics. So all these, level 1 to level 5 can be a step-by-step approach, right, towards machine health monitoring and improving your overall machine utilization. And of course, in SHRDC, what we do is we translate whatever that we develop into high-impact training programs. Therefore, each level of the data automation maturity level are packaged into programs, right? So if you want to get started, you can start off at level 1 or even level 0.5, right? Level 0.5 is actually more for the management level and the overall, level of engineering managers to look into what are the technologies there to support their industrial 4.0 applications. Then you look into more technical programs like, level 1 for data generation, level 2 and 3, which is machine data logging and visualization, level 4, which is OEE, and then level 5, which is data analytics. So the whole idea about focusing on open collaborative platforms is to ensure open and scalable technologies, helping industries to start off at a lower upfront investment. And the idea of it is always readiness to replicate. So the maximum value creation that can happen for any industry, we believe, starts with digital transformation ownership, right? Sustainable technology integration, and therefore overall improvement in your ROI, right? So if you start with a very, very cost-effective step, you improve your overall ROI and you can see greater productivity over time. So essentially what we do at SHRDC under the Malaysian Smart Factory is that we focus on tech talent development. We also do technology learning platform where once this MCO period is lifted, we are more than happy to have you all at our site, right, to actually see the Smart Factory in real life. Right, we do a lot of proof of concept and lighthouse projects. So industries that intend to look into digitizing certain operations, we are more than happy to look into your problem statements. Live demonstration of technologies where we showcase technologies happening in our center at the moment, right? Digital training platform, right? Right now with the pandemic situation, we have actually launched our remote online training, right? Therefore, at the comfort of your office or your home, you can actually conduct or do your training, just by logging into our equipments, do the hands-on training remotely, right? And still obtain the right skills and competencies to start your Industry 4.0 journey. So with that, before I end my presentation, do get in touch with us if you intend to talk to us more about your journey, right? We are more than happy to support you all the way. All right, so thank you very much. And here is a QR code for our virtual tour if you intend to have a look at the Smart Factory, and do get in touch with us in due time. Thank you.
Thank you, Dr. Chua. It is indeed really insightful. Actually, it's a lot of it is a lot of information to digest. But I think to maybe take a few notes out of it would be, let's hope we don't see the smoke coming out from the motor. Then at least we know that our machine is actually running correctly, So I think this is where, let's hope we don't have not too much noise or too much unusual noise or too much unusual heat, which would create some smoke in the motor. So hopefully we don't get to that portion, and then we can actually maintain our motor at its optimum level. Thank you very much, Dr. Chua, again. Next up, we have Frederick from Baloof Automation. So let me give a brief introduction on who Frederick is. Now, Frederick has been in the automation industry with Baloof since more than 4 years. Coming from the background of mechanical engineering, he started as a global key account manager in Germany. Later on, he took responsibility in supporting sales subsidiaries around Asia Pacific with focus on business development. Since beginning 2020, he took a new challenge to set up and lead the new Baloof entity in Malaysia. Baloof is one of the leading providers of industrial automation equipment with focus on sensors, IO-linked devices, and RFID technology. They are promising their customers to make them more competitive and deliver the best products for their Industry 4.0 approach. The screen is all yours now, Frederick.
Thank you very much, Kenneth, for the introduction. And I'm very happy to be here in this webinar, and I'm also happy to be in Malaysia, to be honest, even though it's tough times with this corona pandemic. But I'm glad we come together, also it's online. And so I would like to share my screen in the beginning.
Yes, please.
Okay. So yeah, the topic today is optimizing machine utilization. And Baloof is a quite new company in Malaysia, and therefore I would also introduce my company with a couple of words in the beginning. So, okay, Baloof has globally more than 3,600 employees. So we are a quite medium-sized company with headquarters in Germany, and we basically provide automation solutions. We have more than 37,000 different sensors, identification and networking devices, and we also have 37 subsidiaries all around the world. The newest, most new subsidiary is actually here in Malaysia. Last year, we incorporated Balof Automation Malaysia, Sendirian Berhad. So you can see here on the right side a picture of our KL team and of our office. We are based in Puchong in Selangor, and here's our head office as well as our warehouse. Yeah, you can see we are just in September last year, we just incorporated our office. Before that, we actually were active from Singapore. So we have one very important sales office in Penang, and we also serve the Melaka market as well as Johor, and we actually plan a new sales office in Johor within the next 1 or 2 years. So, okay, when I was invited to this webinar with the title Optimizing Machine Utilization, I was wondering, okay, which of our 37,000 products could we actually introduce, and what is the topics that the manufacturing companies and end users in the current times, what might be their challenges, what might be the topics most interesting for them. So I came up with 3 topics that I want to enhance today. One is the machine downtime. Of course, all of us, we are trying to avoid the picture on the left out of order, but we are trying to use the machines as much and as often as possible. Second topic is machine monitoring. So, of course, Industry 4.0 is a big topic, and many people dream of having a dashboard where they can monitor their machines 24/7 from their smartphone or from any kind of device. So I'm gonna speak about this topic quickly. And finally, also the machine flexibility can help to make machines more utilizable and to increase the usage of machines overall. Okay, so yeah, when I was thinking about our 37,000 products, which one should we focus on? The question was, the answer was actually quite easy, because there's one technology called IO-Link, and this is one of the most important enabling technologies in this century, I would almost say. And yeah, so therefore I would focus my presentation on the topic of IO-Link. My agenda would be to quickly introduce IO-Link, what exactly is it, and then quickly speak about the 3 topics I just mentioned. How can we decrease machine downtime? How can we monitor a machine? And here we also have a quick live demonstration of our sensors. And finally, how can we make machines more flexible? Okay, so what exactly is IO-Link? One of the easy definitions is IO-Link is a smart, easy, and universal way to connect devices into your control network. Okay, so to make it a bit more understandable, I just copied the industrial pyramid, the automation pyramid. And you can see on the top the PLC level, and you can see on the bottom the sensor actuator level. And basically IO-Link is everything in between, it's covering everything in between. You can see the second level down here is the field bus level. And here you can see the most important IO-Link product, which is the IO-Link master. And to this master, you can then connect several sensors and sensor hubs. So you can use IO-Link sensors, you can use normal sensors. So basically this is to symbolize that IO-Link is here in the middle, giving the interface between controller level and standard sensor level. So to have an IO-Link system, what is the components we actually need to have an actual IO-Link? First one, we need this IO-Link master that I just mentioned. We can also call it a gateway. So the master looks like this. We've got 8 ports to connect 8 sensor or hubs, and the master comes with a GSC file or EDS or XML file, depending on what PLC you actually use. Second of all, of course, we need a sensor. So an IO-Link device. For this example, we use a Balluff optical distance sensor. And every IO-Link device actually comes with an IO device description. Okay, so the description actually contains information about, okay, who's the manufacturer, what is the material number, and additional information about the device. And finally, to connect these two, we also need a cable, obviously. Okay, so in IO-Link, everything works with a standard, unshielded 3-wire cable. The maximum length is actually 20 meters. But very important is to know that we actually use a very, very easy standard cable. Okay, so what I mean, yeah, this looks still very easy and not too much different to your existing layout, maybe. So what exactly is the difference? What is IO-Link actually doing in the background? It's about the communication. So IO-Link issues a serial telegram to communicate to IO-Link devices. And in this way, the same cable can be used to integrate intelligent sensor together with any standard sensor. So, okay, to understand this a bit better, I've just copied this table here, created this table. So on the top, on the first line, you can see standard IOs, input outputs. As you know, standard input output is 24 volt, basically on or off, and it's basically a 1-bit data, which comes in a cyclical time pattern, and the transmission time is quite easy. Okay, so this standard signal is still included in IO-Link, it's also covered, but with IO-Link, as I mentioned, we have a serial telegram, so you can see here the signal with a serial communication looks, for example, like this, and by doing this smart communication, we can transfer additional information, not only 0 and 1, but we can actually transmit process data of the input and output, as well as, this is the most important part, service data. So what do we consider as service data? Is, for example, the device parameters and diagnostic data. Okay, so there's additional information that the sensor feedbacks back to the controller using IO-Link. In total, the data can be up to 32 bytes. So that's a lot more, obviously, than a standard input-output. And therefore, also the transmission time actually increases. It can be, if you use the full data volume, it can be up to 32 milliseconds of transmission time. So yeah, here you can actually see the wiring. Pin 1 and pin 3 is used for the power, plus and minus, and pin 4 is typically used for standard input-output, as well as IO-Link communication. Okay, so on one pin, both communication protocols will be feedbacked to the PLC. One very good advantage of IO-Link and of an IO-Link master is that we have the option, or basically the advantage is that the master comes with its own IP address and a web server is running on the master itself, which enables a connection to any kind of computer. So the interface is called a RESTful API, but in the end, you can connect the master to any computer, which then allows you also that the master can communicate with higher levels of any other systems, for example, the cloud. So on this picture, you can see the master being connected to our PLC. In this example, we use a Siemens PLC and Trophy bus protocol. But actually, on the right, you can see we have different masters for any PLC bus protocol. For example, CC-Link, CC-Link IE field, DeviceNet, Ethernet IP, and EtherCAT. So yeah, on the right side, this is the connection to the PLC, whereas we could also connect the master straight away to a PC. So what would happen here is, this is basically the access. I put the picture here. This is the access to the web browser. So on your computer, you could configure each port for what information do you want to receive, input, output, or IO-Link. And then from here on, yeah, there's basically no limits on how you want to use the data. And for example, you could upload it to a cloud. You can visualize it to different dashboards. And we will give you one example later how it could look like. Okay, so yeah, coming to the next topic. How can IO-Link, this technology, help to decrease the machine downtime? So one is, we get additional information. We get information about the condition of the sensor. Means we can predict the maintenance intervals and we can plan the downtime. So means we can, yeah, basically decrease unplanned downtime, but we can actually say, okay, this sensor or this machine has to be maintained next week because the parameters look like this. Also, IO-Link enables a quick exchange of sensors. So I didn't mention it yet, but every connector is actually standardized to M12 and with this 4-pin or 3-wire cable, as I said. So it means the cable is always standardized, so you do not really need a hard wiring process. You can, everything is with the same connector type. Another advantage is you can store your parameter on your PLC, and once you connect the sensor, you can actually configure the sensor from your PLC. Means the parameter data will be sent to the sensor and straight away be functionable. And then I also mentioned before the device description means you can identify every device. Means you actually have the possibility of auto-scanning all the devices that are connected to our controller, and it will give you a nice list of all IO-Link devices connected to your current system. And finally, by having an identification of each sensor, you can also not really confuse them because, yeah, it's basically unique descriptions for each sensor, so you can't mix them up with each other. So I put this picture here, which is actually very similar to the IO-Link topology. It's really that easy. It's just plug and play, like an easy power plug. Everyone can start using a power plug, and that's almost the same as using an IO-Link device. It's just plug it in and it basically works. One topic that can also help to decrease your machine downtime is inventory management. Typically, it's done via RFID technology. So you can see here on the little picture that these workpiece carriers, they have a small, in black here, a small RFID tag. And basically all the carriers are tracked and traced amongst your production, so that you can collect information about which machine has been used for which process and so on. So it's a very, very big topic, RFID technology, but in today's topic, I do not want to focus on it, but I want to mention that RFID is also compatible with IO-Link. So it means we have RFID read-write heads that can directly be connected to IO-Link master. Okay, so now we come to the second topic of machine monitoring. One example that we have for giving additional information is a smart power supply. So it means the power supply gives typical 24 volt, but it actually also monitors its own process, its own data. So the information you get from the power supply through an IO-Link interface is you get how much voltage is currently used, how many amps are currently drawn from the system, and what is the resulting watt. number out of these usage data. And finally, you can see here, I zoomed in a bit for the ones that don't have that sharp eyes. You can see 3 indicators here. So stress level, this is actually the current amps which are drawn, the load level, which is the current voltage consumption, and the lifetime. So lifetime is actually the perfect example of the power supply giving you an estimated time of when is the next time that you have to maintain the power supply. And also, obviously, power supply gives you information about all the sensors connected to your system. So this is one very good example of a power supply, usually a standard product, but with IO-Link, it gives you additional information about your system. Another example is a condition monitoring sensor that actually gives you vibration, temperature, and other values. So this is also the sensor we would like to focus on in our live demonstration in a minute. Usually, this kind of sensor is used for motors, pumps, and valves. You can see here it's usually big devices or big machines. Actually, in our office, we did not have any of these machines, so we used. So the only machine we were able to find was a coffee machine, which is also working very fine. So I'm happy to share our coffee machine findings in a minute. So just quickly on this sensor. The sensor looks like this. In this housing, there's actually multiple sensors installed. It's a vibration sensor, temperature sensor, ambient pressure, and humidity sensor, all included in this one housing, as well as a little microchip. So the sensor is able to pre-process the data, okay? So for onboard calculation of statistical parameters. And it also can store information about the events, means like what thresholds you want to set to maybe cause an alarm, or to maybe for any kind of actions and alarms. What is the thresholds that you want to define? This is what you can store directly inside the sensor, this information. So the whole sensor comes in a IP67 or IP69K housing. Of course, it has an IO-Link interface, as you can see here, the symbol on the right side. And it comes again with our standard M12 connector. So this is what we will show you now through our second webcam. We have a coffee machine on the left, and we mount our condition monitoring sensor on the machine. It's connected to our IO-Link master. So this is a small version of the IO-Link master. It has its own IP address. We connect to the web server. The data is actually visualized in Node-RED. Or basically, there's a data model behind, and the final result will look like this. It's an actual dashboard of giving you information about 3-axis vibration. So you have X, Y, and Z axis. And we also can see the temperature. Okay, so I'm gonna stop sharing my screen and hand over to Amar. And let's see if our coffee machine can perform well today.
So thank you, Fred. So yeah, actually this live demo is supposed to be in SHRDC class, which they also got this one DC motor so that they can monitor this via vibration of the motor. So the idea is when they tighten the cables, the cable chain, and then it will be less vibration. But yeah, since we are in this COVID, and then our government announced there's gonna be an MCO, so we find our own solution. So let me just share our screen. We are using coffee machine like Fred mentioned just now. Okay, so as you can see, this is our coffee machine, and like Fred mentioned just now, in order to use IO-Link product, first you need a gateway. So this is the gateway with 8 ports. And then the first port here are configured as IO link. Okay, and then this is the vibration sensor that is connected on the first port. Okay, and as you can see now, it's connected to this metal base of this coffee machines. So in order to display this value, I'm using a Node-RED. So I'm making my laptop as my server, and then here is the flows that I'm using. So I get the data. Oh, sorry. So then let me just share. Let me share my whole screen. Okay. So this is the flow, Node-RED flow for this software. And as you can see, I'm using RESTful API. So here I'm using the IP address of the master hub itself. And then I expand it to show this X, Y, and Z. Okay. So this one actually the vibration acceleration that I'm monitoring for the coffee machines. And as you can see, so please take note, here is the value that I'm showing right now. And then here is the graph plotted between time and then the angle. So before let me show you this when I try. So as you can see, now I'm getting all direction, okay, for X, Y, and Z. And if you notice for Z direction, it stopped a little bit and then it started to increase back again, the vibration. And we got a higher peak also at Y direction. Okay, so actually this kind of data we can also view in ISO standards. So if I'm open up. Okay, so by following the standards, so let me explain a little bit here. Here it falls into 2 categories based on ISO 10816-3. If you mount your pumps or medium-sized machine motors or valve on a rigid or flexible places, then you can monitor this velocity for each value. Example, if I'm mounting my pumps on a rigid ground, that means if I'm having 1.4 or 2.3, I'm still at 1.4, I'm still in good condition. But when I'm start rising up to 4.5, there is a short-term operation allowable. Okay, and then if I goes more than that, then the vibration will cause damage to the motor or machines. So this is like a guideline that we can follow based on the ISO standards. And other than that, these sensors as well, I'm plot the temperature as well for the graph. So as you can see now, if I'm moving near to the cups of this coffee, so the temperature keep increasing and increasing. So yeah, so you can monitor these tool, all of these 4 data. So as you can see, it's kept increasing 3.33.6.8. Yeah. So I think back to Fred.
Okay, thanks Amar for the very quick demonstration. I'm glad to find that our coffee machine is still healthy. It's on a healthy level. It was below 1.4, I believe. So, okay, we can still use it. Okay, so quickly back to the demonstration, to the PowerPoint. So, okay, yeah, this is what we just showed. The sensor was actually mounted here on this metal grill, and when the temperature went up, Amar actually threw the sensor inside of the cup, so it increased. And the sensor is IP69 69K. So yeah, no problem about any water or coffee close by, no problem. Okay, so the last quick topic is machine flexibility. So how does IO-Link support your machine being more flexible? First of all, it's a simplified architecture in general, the IO-Link. Again, you see the master, and it's connected to a different kind of sensors and hubs, always using the same standard 4-wire cable, and it's also using a digital signal. Means you don't need a shielded cable. You will not have interference, excuse me, with any parameters close by, but it's a stable connection. All the sensors, including the master hub itself and the hubs, is IP67, means you can place them outside of the machine cabinet. So it gives you much more flexibility of designing your machine. You don't have to wire everything back to the cabinet, but you can just place it anywhere where it's convenient for you and where you can save some wiring and cable effort. I already mentioned that we have masters for all kind of bus protocols. So here I can connect to all PLCs, as well as you can connect to any kind of computer using web browser. You have an easy format change, because the PLC will auto-teach sensor parameters when you have a different product. It's quite typical in the nowadays production that you, let's say, you want to manufacture 2 types of products with a different size on the same machine. So it means you have to teach the machine, okay, now this is the end size of the product, and then you put a bigger product on the production, and of course all your parameters will change. So you can auto teach that to the sensor using the IO-Link from your PLC. A very good advantage is also that you can connect digital as well as analog sensors. So both signals can be transferred using IO-Link communication. And finally, also very important is IO-Link is basically a world standard. There is a DIN international standard norm behind, and on the picture here you can see all the brands which is using IO-Link, and all the devices is compatible to each other. Means you can use a bulb sensor and connect it to any other brand's master, or the other way around. Means you're not really focused, you're not committed to one brand only, no, but you have the whole market open for yourself. Okay, so yeah, these were a few short insights into IO-Link technology, and we are very, very confident to say that it can increase your productivity. We have experience with IO-Link since more than 15 years in several countries and a lot of happy customers. So please contact us in case of any questions. My contact details is here, and we are happy to have given you a short insight into IO-Link and Balog as a company. Okay.
Cool. Thank you very much, Frederick. That was a very, very interesting presentation, actually, especially with the live demo and the coffee machine. So now we'll open up to the screen now, definitely for Q&A. If you have any Q&A, gentlemen, please do let me know, voice it out, and then we can proceed from there. All right. But first and foremost, I think what will be interesting is for laymen, right? Which means for factory owners especially, what do we mean by IO-Link? Right? Because from what I've seen so far in your presentation, Fred, that it seems like it's like the master gateway kind of thing, and also if you have the key, then you can connect to almost everywhere kind of thing. But what does it really mean, actually?
Actually, it's a good question, Kenneth. I hope some of the listeners could already give the answer out of experience, but a typical misunderstanding is that IO-Link is a bus protocol. No, it's actually not. It's not the same as Profinet or Ethernet IP. It's actually the communication to connect your controller to the sensor. Remember the pyramid? So basically, it's the whole connection from your controller on the top down to sensor. and it's a bidirectional communication which gives additional information, not only input and output data, but also additional diagnostic and parameter data. So in a summarizing words, for me, it is the communication standard of Industry 4.0.
Ah, okay, nice. All right, so that gets it out of the way. Then I noticed as well that there's a maximum length of the cable, which is 20 meters. All right, I know normally it is made for a bit longer, and I assume that 20 meters is the ideal length. But is it possible that we go further? I mean, of course, we don't want it to go further, but longer anyway. But is it possible that we go for a bit longer kind of thing?
Actually, IO-Link is limited to 20 meters from one point to a second point.
Okay.
But it also is possible to have several points. Means you can go from one sensor to the hub, you have a 20-meter connection. Then from the hub to your master, you have another 20 meter. So you end up having a total of 14 meters. But we cannot go to hundreds of meters as you would go with bus protocols, for example. IO-Link can actually not do this. So we are limited to roughly 14 meters.
Okay, all right, thank you so much. So now I think in the one of the participants has a question. So this guy called Mupafna. Now he asked if the master unit, is it sold separately or is it bundled with sensors? Because they are IoT sensor makers and they have sensors with IO-Link interfaces. And can it be linked to the master unit as well?
Okay, thank you very much for this question. The answer is very easy. All IO-Link devices can be purchased individually and can be linked individually. Also, as I mentioned, you can use any brand and combine the sensors and masters separately, up to your selection.
Okay, so but as long as they use the same protocol, then it's fine. Sorry,
exactly.
Same communication protocol, right?
Exactly, the communication protocol will be IO-Link.
Yeah. All right, cool. Now, on another note, Dr. Chua, we always talk about sustainable growth and sustainable digitalization and so on and so forth, right? And of course, we understand that Baloof as well has a lot of sensors. And from what I've seen so far, today's sensor, well, I used to be an engineer many years ago, so those sensors were very easy, on, off, or just maybe measure a temperature kind of thing, But if you want to measure X, Y, Z axis, including the temperature, then I think those days you pay a bomb for it. But nowadays, I'm not too sure. But in this day and age, are they sustainable as well? Maybe, I'm not sure whether is it Baloof or SHRDC can take this question then.
Okay, so maybe from my side, what I will share is some sensor technologies have definitely advanced through the years, right? In fact, the one that we are currently putting in as a demo from Baloof actually is quite complex and quite sophisticated in terms of technology involved, right? It can measure the three-directional vibration, temperature, and also pressure, if I'm not mistaken, right, Frederick? So those sensors, are very, very good because those are, sensors that can already measure a lot of parameters that you will need for, condition monitoring of a machine. So definitely, I think in terms of the longer term scalability, right, and sustainability, those are something that we can definitely look at in the near future when we look at machine health monitoring systems. Yeah, so in terms of sustainability, I think that the sensors offered are actually good. Yeah.
Frank, do you want to add anything to it?
Just want to add in general, it does look a bit complex, and I do agree compared to maybe 15, 20 years ago, the sensors is much more complex, but mostly on a software side. But this is also the typical development of the fourth industrial revolution, that we collect more data, not only standard inputs and outputs, but actually we want to have more, we want to monitor the whole machine. So therefore, as Dr. Chua said, it definitely is sustainable, and actually it's the right way to go.
All right, nice, fantastic. And I like doing the coffee machine live demo. Now that's interesting because I noticed that there's an X, Y, and Z axis, and then of course there's a temperature that we also measured as well. But maybe pose this to Baluf as well. Now, how do we compare these graphs to? I saw that you actually compared with ISO chart, but assuming if we do a machine, then how do we compare this with? Amar or Fred?
Okay, so for this one, actually on the sensor itself, you can set a set point. Okay, so example, you can make, if I set based on the graph, let me just share my video again.
Okay.
So I can make a set point here. Example, if I make it give an alarm, pre-alarm, I can make pre-alarm at 3.5 velocity value MMS. MMS 3.5 millimeter per second, and then I can make it as pre-alarm. So I can make it achieve the alarm. Example is exceed more than 4.5, then I will get an error over here. So this one I can make it in the controller itself, one part, or I want to set on the sensor itself. It also possible for me to do set point for this.
Okay.
So it depends also how you mount your machines. So this is the guide that we can follow based on the ISO standard.
Right. So if I understand correctly, Amar, just to clarify as well, so as long as we compare with the ISO specifications of the machine, then we are more or less correct.
Yes, you are right.
All right, fantastic. Okay, that's good. Look, there's another question on data visualizations. Now, I noticed that in Baluf, you all use Node-RED to actually get the data. Right?
Yes.
So is this monitoring app an open source or is it brand dependent? Or,
okay.
Yeah.
So this one is actually open source software that you any levels of industry can use, education can use, even freelance they can use as well,
Right.
or a factory they can also use this to monitor their small scale of their factory. So yeah, it's an open source, and then we also use this kind of direction so to easier for our customer to use it. And for us, yeah, we are also support after sale as well to support them on how to use a Node-RED. Yeah.
All right, that's nice, fantastic. So I don't think there's any more questions from the, no, I wanted to say floor, but it's not, there's no floor, but there's a screen now. So, thank you very much. Just as a quick wrap, all right? So I like the part where Dr. Chua actually shared his viewpoints about SHRDC and how we can actually keep machines optimal, all right? Then of course, what was interesting is we can actually use sensors nowadays, which is now more advanced, all right? And of course, sustainable as well. And what was interesting is instead of whether I mean, we can also use the practical day use where we can actually test using the coffee machine to see whether the machine is healthy in this case, you know. So this is interesting actually. So now, as a quick wrap up, so just to give a brief introduction, so my name is Kenneth. So we are actually sales partners with the Malaysian Smart Factory 4.0 with Dr. Chua and of course Supling. So we have monthly courses for data generation, of course, machine data logging. So do call us and do speak to us as well. What will happen is we'll send you the link for this video shortly once everything is done. We again apologize as well because we need to do a re-recording. So thank you so much for your patience. Just as a quick thank you very much for all concerned. So we would like to invite, of course, Dr. Chua later and of course Fred later to give a few parting words. Dr. Chua, do you have anything to add?
Yep. Thank you, Kenneth. So I think in terms of starting your digitalization journey, I think it is shown from Frederick's presentation and also demo that sensors nowadays are very smart, right? Smart sensors and very easily integratable and configurable. So I believe that there shouldn't be a big hurdle or challenge to actually get started on your journey in terms of machine health monitoring. And I would definitely encourage everyone hearing this webinar session here today to actually get started. And SHRDC and I believe Baluf are more than happy to support you all the way through.
Thank you. Frederick?
Yes, I can just agree to Dr. Chua, and I'm also happy to have the partnership with SHRDC. I'm always happy to be invited to your Malaysian Smart Factory and to investigate further on how we can also educate the industrial group about sensors, about Industry 4.0, about multiple topics. And Balov in general is very happy to be in the Malaysian market and to deliver the components and the hardware for any kind of industrial needs and solutions.
All right, thank you very much. Thank you very much. Thank you very much again, gentlemen. So with this, bid you adieu. In the meantime, please stay safe. All right, it's crazy cases out there though. All right. So thank you very much again. Yeah.